Cross product. The cross product of two vectors u and v is the vector defined by any of the following equivalent equations. The first equation writes the cross product as the determinant of a 3 by 3 matrix, where the top row contains the three standard basis vectors instead of numbers. That is why this is just a mnemonic device used to remember how to compute the cross product rather than an actual determinant. If we proceed with computing the determinant of the 3 by 3 matrix, the result is a vector that contains determinants of smaller 2 by 2 matrices. Finally, after calculating these actual determinants, the result is the final equation for the cross product of two vectors. The cross product of u and v is orthogonal to both u and v. That is, it makes an angle of 90 degrees with both u and v. The cross product of u and v is read as u cross v. Consider two vectors u and v, and theta be the angle between the vectors. The cross product of u and v is this vector that is perpendicular to both u and v. Which means it makes an angle of 90 degrees with u and v. U cross v is not the same as v cross u, because v cross u points in the opposite direction of u cross v. In other words, the cross product is not commutative. However, the negative of v cross u is equal to u cross v. Nevertheless, we learned that equal vectors will have equal lengths, and the length of a scalar multiple of a vector is equal to the absolute value of the scalar times the length of the vector. So the length of u cross v is equal to the length of v cross u.